Hi again. Today we're talking about percent composition by mass, which is kind of a long title, but it's an important concept. And as we try to figure out what a chemical formula is made of, it's going to be a really important first step. We're also going to prep for a lab that we're going to be doing fairly soon after watching this video. So when we start talking about a chemical formula, this is the question, and we've kind of taken it for granted, I suppose, a little bit when we've done nomenclature and things like that this is a chemical formula. But someone, somewhere down the line, had to sort out that chemical formula. This is what's in there, and this is what it's made of. A few background things that we need to know, or need to remember, I guess. One is that a chemical formula is a ratio of numbers. So when we look at a chemical formula, water, for example, it's 2 atoms of hydrogen, 1 atom of oxygen. Now what we can do now is talk about that in terms of moles, so 2 moles of hydrogen for every 1 mole of oxygen. But the bottom line is it's still about numbers. And if I did the same thing with this one here, okay, I've got 3 calciums, a total of 2 phosphoruses, and 8 oxygens, I'm still counting numbers. Whether or not I'm talking about atoms individually or moles of atoms collectively, I'm still talking about numbers. The other thing that I have to remember is that atoms are really, really small. So even if I'm talking about moles of atoms, I'm not counting individual atoms. But then the other problem is, whether I'm talking about moles or individual numbers, I'm not able to count those out as individuals or as groups. So if you think about when we were using moles, we always had a connection with mass. If I know the mass, now I can work with the numbers of moles. So that was my connection. So we need to be able to do a similar kind of thing here in order to go from something that I can actually work with, masses, to something that the chemical formulas work with, numbers. So take a bit of a side trip to see if we can understand what's going on a percent composition, because we know how to do percents. We know how percents work, but the problem is we're most familiar with percents when we talk about test scores. And when we talk about test scores, we kind of know what to do to find the percent. Well, we would take what we got, the amount that we got, divided by the total amount that it was out of, and then do the division, multiply by 100, do some stuff. Sometimes we just do that part in our head and we end up with roughly 82%. We want to apply exactly the same principles to atoms, molecules, and compounds. Okay? And I could express it this way as well. Okay, what if it's not a test? A percent is still a percent. So if I had a bag of jelly beans, okay, and I had this kind of ratios going on in my jelly bean bag, then I could, if I wanted to find the total mass, and if I wanted to find the percent that was orange, I would take the amount that was orange and over the total amount that I had. Much like a test, the amount that I got right divided by the total amount of the test. The amount that is orange divided by the total amount of jelly beans. Do that kind of math and I end up with, oops, I thought I actually had the percent there. I don't. I don't really care how many orange jelly beans there are. Okay, now we're getting into the chemistry side of things. So if you wrote that stuff down, that's cool, that's awesome, but you're never going to be asked about jelly beans, and you already know how to do the test. So, compounds. If I had a compound and I was able to figure out the mass ratio, how the mass is related to each other in a compound, and I'd be asked to find the percent composition by mass. And this is a fairly typical kind of question. And when we do the lab, our job is going to be coming up with these numbers, not for sodium and chlorine, but for other things. Wouldn't that be great if I gave you chlorine in a lab? It's not going to happen. Okay, you need to know the total mass. What was it out of? What was the test out of? What was the total amount of jelly beans in the bag? What's the total amount of stuff, compound, in that compound? Okay, so you know the total mass. Then say you want the percent that is sodium. Well, how much is sodium? How much was orange? How much did you get right on the test? Divided by the total amount. And that's it. That is all there is to it. Really easy. Okay, I'm going to give you one for you to try. And if you need to pause it to write it down, if you need to pause it to figure it out, awesome. But you're going to then find the percent of sodium, and there is your answer. And if you didn't do that, please do that. Okay, same thing with chromium, and we could do the same thing for oxygen. I didn't write the formulas in there, but you know what to do. Okay, now sometimes we know the chemical formula. Sometimes we know the atoms involved and how many of each, and we want to know the percent composition. Okay, so what we could do is we could take the formula and say, what if I had 1 atom of zinc, 1 atom of sulfur, 4 atoms of oxygen? Same kind of thing. To find the percent composition for zinc, I need the mass of zinc divided by the total mass. But if I have the chemical formula, that gives me a couple of things. It tells me how much zinc is in there, and it tells me the total molar mass. So I would find the total molar mass. Then I would take the amount of mass that was zinc, and if I had 2 zincs in that formula or 3 in that formula, I would multiply by 3 or 2 divided by the total amount. So the total mass that is zinc divided by the total mass that is compound to get my percent composition by mass. Okay, that's pretty much it for percent composition. We want to talk a little bit about the lab. So in the lab, what you're going to be doing is you're going to find the breakdown of magnesium and oxygen in magnesium oxide. And you're going to, if you have your textbook, you can find it here, but if not, that's okay. I'll just give you the rundown here. You're going to do an experiment to find out experimentally what your percent composition is. You also want to be comparing it to the theoretical, just to see how good your results were. And we actually do generally get very good results out of this lab. Okay? So you'll need the mass of magnesium. You'll need the mass of oxygen, which will be a little tricky to get, but not really, simply because oxygen's a gas, so you can't put that on the balance right away. And then you'll need the mass of the final compound. Then you're going to compare that theoretical. Now theoretical is what we just got finished doing with that zinc sulfur oxygen compound. You know what the chemical formula for magnesium and oxygen is when they form a compound, so you could come up with the theoretical, what you expect. You could actually do that right now if you wanted. Not a bad idea. Do that before the lab, extra practice. Okay, you're going to have a data table that looks something like this. So you're going to be finding the mass of a crucible and lid. That's just a container that has a lid on it. And then you're going to put some magnesium into that crucible. You're going to do some stuff to it. And when it's done, what you should have is magnesium oxide. So you find the mass, 3 of those masses, the top 3. The bottom 3 masses, that's where you ignore the container and just get the data that you need for the lab. So it's these bottom 3 masses that you're going to be using in the actual calculations for percents. There's going to be a lot of steps. It's actually going to be a fairly long lab, but really all you're trying to do is get these numbers. And after that, there's not much more to it. So, percent composition, important first step for a bunch of things, so make sure we understand what's going on with that. Important thing for the lab that we're going to be doing, but really, as math goes, it's pretty simple stuff. And yes, we'll worry about significant digits and sig figs and that kind of thing too. Talk in class.